Hello, 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 and welcome to another episode of NextGen Industrialists, Revitalizing American Dynamism, the podcast where we dive deep into the forces shaping the future of industry, from advanced manufacturing to industrial automation, supply chains, and regenerative capitalism. I am your host, Belinda Ibrahim, founder and CEO of Catalyst Point. At Catalyst Point, we advise purpose driven entrepreneurs, manufacturers, distributors, and technologists through the complexities of mergers and acquisitions to achieve game changing exits, 8 and 9 figure exits, from pre exit planning to selling their companies and supporting them through the post exit integration. Today, we are diving into a topic that challenges everything you thought you knew about food waste and profit. My guest, Michael Sigel, CEO of SCO2, isn't just talking about sustainability. He is revolutionizing it by turning what others throw away into $300 million opportunity. Through innovative waste valorization, from orange peels to banana skins, grape skins, pomegranate skins, and discarded spent grain, among many other industrial waste materials, discover how SCO2's patented supercritical CO2 extraction system and breakthrough approach could eliminate 100 million tons of food processing waste annually while generating new revenue streams for global food processors, manufacturers, and agricultural farming businesses. Hi, Michael. Welcome to the show. How are you doing today?
I'm I'm doing great. Thanks so much, Belinda.
Good, good. No, it's great having you on the show, and this is an interesting topic, and we are going to get right into it. But before we begin, I want to thank you so much for spending quality time with me. It is a real privilege for me to invite people into conversation. So when I do these things, I always liken my interviews to the indigenous traditions of storytelling in communal experiences. I am going to start, but before I do, I want you to know that you are in absolute control. You can choose to not answer a question or answer the question any way that you want to. So, Michael, what is your story?
Well, thank you for what a great introduction, and thanks for all your help in putting this together, and for what you're doing and helping people like me tell my story. I think about my story and maybe a little bit of the legacy you want to leave, and I really grew up in a really entrepreneurial household. Both of my parents, my mom and my dad, built very innovative and successful businesses at their time. My dad was in the food industry. My mom was in the interior design industry. And I think what is really interesting, and I look back now, is I think I learned a lot. You kind of become a product of your environment. And I think I learned a lot of the values that they had that I now, possess, I think, as an entrepreneur, because I literally grew up with these kinds of values around, problem solving, vision, work ethic, certainly resilience, positivity, industriousness, integrity. And I probably didn't know it at the time that I was learning these things, but I really grew up in that. I grew up in the great state of Minnesota, moved away twice and came back like a good Minnesotan. That's what we're supposed to do, apparently. But a great place to grow up for sure. And I really followed in those footsteps that were that path that was paved for me as an entrepreneur in early stage and emerging growth, mostly food companies and related companies. Some of them were literally brand new, never selling a product before. Some of them were of my own making. And I was really trying to grow them and scale them, with the idea of the greater good in mind, and bringing really innovative things to market where, we saw some white space. And I've been very blessed to be able to do a whole bunch of great things in that. And SCO2 is a really great opportunity for me to take all those skills and put them together. And it's a big challenge, but also something that, I lived it as a food manufacturer, dealing with our own waste. And I just know we can do so much better.
Yeah. So it sounds as though you've really grown up in this industry, as a child, having parents who were entrepreneurs in the agricultural industry space. And then you yourself were also, it sounds like, a food manufacturer, and having to deal with the problem, I would assume, that the founders were trying to solve for people like yourself, business owners like yourself. So then what was then how you were manufacturing, you had your own manufacturing company, they had this solution to one of your problems. How did the two entities connect?
Yeah, I started my career in selling better for you frozen baby food. I went into different products from there and do cheese, as a cheese manufacturer, making Hispanic cheeses, making functional beverages and things like that. And I just saw in each of those manufacturing environments that we had byproducts, and I didn't think that much about it at the time. But I met the founder of SCO2, who had a very different background than mine, who was really more on the engineering and the development side of industrial processing for a number of different kinds of wastes. Everything from, I think he started his career in nuclear waste, containment, municipal solid waste, recycling, and had developed with our other co-founder an opportunity to deal with food waste through a really innovative extraction system that was very different than what exists today, but leveraged some core principles of using supercritical CO2 to do that. And what I really saw, and admittedly, when I first talked to him, I didn't really understand what he was talking about. I never really gave a lot of thought to how a lot of the things that are in our daily lives, like you think about the foods that we eat, the personal care products that we consume or use on a daily basis. Everything from our toothpaste, our perfumes, flavors, everything from your vegetable oil to a high-end perfume to things that are in our nutraceuticals, our supplements. These are all plant-based compounds that were extracted by a plant somehow. And what I saw as an opportunity, and I have to, kind of give this disclaimer, I'm not a scientist, I'm a business guy. But what I saw as an opportunity is not only did we have waste in those food manufacturing processes, but we weren't doing a whole lot with it. As I learned more from Olaf and Greg, the founders of SCO2, I was like, God, if we could come up with a way to kind of match this technology with this really big problem and do it at a scale that would matter. And I think that was really the key for me, is quizzing them on how could we actually process enough material to make a difference. That's really when I got really excited about it. And that's when we decided to join forces and really demonstrate a whole new way of thinking about this and then applying it.
So typically in the startup space and just business in general, most founders don't really understand the concept of what got you from seed to series A or B might not necessarily be the same tools and or skill sets that will get you from series A to series C or whatever the case is. And for established businesses, maybe they're not raising money from venture capital firms, but they too also have to figure out, okay, I can get to 5 million, but what does getting to 10 million look like, and what kind of resources? So it sounds as though the founders and yourself sort of connected on that from that perspective, and they brought you on as CEO to scale the company. Um, Aside from the executive leadership, what other insights did you bring to the table that aligned with your vision for this large scale implementation?
Well, I'd even say that we're even earlier stage, right? This is probably, SCO2 is really a seed stage company with a
Okay.
patented technology, and this is the messy stuff, right? This is where you're trying to find product market fit. Does the solution that you spent painstaking amount of time really thinking about and living and breathing, will the market accept it? Is it the right time? Is it the right solution? Do we have it all figured out? We don't, but we're getting a lot closer, and we believe that what we're doing really has kind of the right dynamics and the right market timing to make that happen. And so what I've brought to the table, I like to think, is the figuring it out part, right? Is how do we do that? How do we take what we have and apply the experiences that we have, and then really go out and actually talk to customers, talk to
Right.
people to confirm, hey, this is the problem that we have, right? We spent quite a bit of time doing that, and really
How long, if you don't
handing it
mind,
out there. Say that again.
about how long did you spend? I mean, obviously that's going to be an iterative process, but how long did you guys really spend, talking to customers and trying to flesh out?
Say about a year.
Okay.
We had some ideas of where we were going to. We always had this idea of food waste valorization and how we could upcycle it into higher value products, but we didn't have our business model completely figured out, because my background with bringing products to market, I'm like, oh, we're going to go pick up someone's waste, we're going to turn it into something great, and then go sell that into industry. Certainly doable. When we looked at it really closely, we're like, is that really the best role for us to play? And so how can we best help our customers get this done? And there's some real logistical challenges with these waste streams because they're very large. They're not stable, and they need to be converted very quickly. And so we spent some time really thinking about the different ways that we could do what we wanted to do and what we thought we could do. And I think at the end of the day, we sat around a table and said, what can we be best at the world at? What is really our skill set with what we want to do based on, and how can we be capital efficient? And how can we leverage an existing ecosystem of producers, suppliers, processing manufacturers, et cetera? And we said, what we're going to be best in the world at is making sure that this technology flat out works in an industrial setting and can be leveraged to be used on as many different feedstock applications as possible. That are, at the end of the day, we're technologists that are trying to now help our clients benefit from the breakthrough. And that was very intentional for, I'd say, one big reason. And that is, in order to make a big impact and make the biggest impact fast, because when we're talking about food waste, it's so massive. It's about 1.3 billion tons of food is wasted a year. We produce over 35% more than we ever can use.
Hmm.
And I think it contributes around 8 to 9% of greenhouse gas emissions, just food waste.
Right.
If food waste were a country, it'd be the third largest emitter behind the United States and China. So for us, there was some urgency here to say, boy, if we could solve something that's really big and meaningful, it only matters if we can go fast, and it only matters if we can go big. So by sort of getting out of our own way and trying to boil the ocean and do it all, and it would take too long, right? So that was one of the real factors where we said, no, where we can go and partner with our clients and help them realize that to everybody's gain.
Exactly. Yeah, because they have the, when you look at the supply chain, in which we can get into further down the road, but those are things to consider. It's like, do you want to own the supply chain? Or right. Because then you're technically competing with your customers and the value add really isn't there. We'll talk about that later. But just so people understand, when you talk about the global impact of food waste on greenhouse emissions, and just when you quantify that so that way people understand it, what is the difference between industrial food waste versus consumer food waste versus restaurant food waste? And why doesn't SCO2, I guess, address all aspects of food waste, and the reason why the company chose to address only industrial food waste?
Yeah, I mean, food waste happens all the way across the supply chain, right? Mm-hmm. From growers, processors, distributors, retailers, our homes, restaurants, et cetera. As it gets further down that supply chain, it becomes more resource intensive because there's been more transportation, more handling, more labor, more water, more everything involved in it. We really focus on that grower and processor segment, which is about 30% of all food waste, because at that point, there's still single stream. And when we're talking about extracting specific compounds, it matters what the input is. It doesn't mean that our system would not be well suited in a mixed waste environment. So if you're talking about our homes or even a grocery store or things like that, and there are other technologies that may actually be better for that. There are a lot of reuse programs. There's ugly fruit programs where, hey, it may not be perfect for the shelf, but still is, delicious and nutritious food. And so when we looked at, how can we, make the biggest impact, we can maybe do it and nip a pretty big part of the problem earlier in its cycle, so less resource intensive. And it was also pretty obvious that the majority of it was going to landfill versus other better alternatives. Right. And so we kind of looked at it from both an impact and an ease standpoint, I guess, is probably the best way to say that.
So food waste right now is currently processed, I would assume, through composting, as you mentioned, as well as shredding. Well,
certainly animal feed is probably the next biggest one. So, in composting, there's there's kind of a hierarchy of uses that and landfilling is the last option. Like that's the worst. We don't want to do that. I mean, and when I was in the functional beverage business, we composted. It's complex because when it amasses, it's there and it starts to rot pretty much instantly. And so you've got to get rid of it. And so we had some farmers that wanted some of our products for animal feed. It's like, candy to a pig is, juice processing waste, juice pulp and things like that. Mm-hmm. The problem we had operationally was both of them were going to be costs. Maybe the farmer would pay a little bit to have this feed source. Problem is I kind of said, we got to take it all or take none, because I can't deal with a farmer once in a while showing up and literally wanting, a few hundred pounds of it, or even a ton of it, when I'm generating so much more. And it became more operationally complex,
Right.
and more of a challenge. There are, and I would say that there are some companies who are extremely good at minimizing waste. And there's not a lot of bad actors out there. There just aren't a lot of great options. And
Right.
so depending on where a company is on their journey, there are some that are really exemplary, that have very green practices that have been around since their inception. And there are others where it's like, we don't have a good option, so it becomes a cost center and they pay to have it hauled away. I think about it as, the mind game is, hey, if I could come up with a turnkey, easy, efficient way to deal with it on site, would people choose to do that? I think they would. There's sort of this internal struggle between the head and the heart, right? The heart knows it's the right thing to do, but the head says, I don't have a good way of doing it. And so the head wins.
Well, and that's where you guys sort of come in as CO2, because it sounds like what you're offering, the supercritical CO2 extraction technology, is a game changer for industrial processors. So can you explain what these molecular supercritical compounds, what makes them so valuable, especially in terms of their applications and market potentials for your customers?
Sure. Yeah. I mean, I think if you think back to, all of these compounds, from vegetable oil to, perfumes and things like that, they're all extracted somehow. And the methods are, they're either essentially you have to strip out the oils or the compounds of interest from the plant. And there are different methods of doing it that require some sort of a solvent that can attach to those and pull it away from the fibrous material to do that. So most of our vegetable oil uses hexane as a stripping agent. And so, very, very large facilities take soybeans or take whatever the input is and strip it out with hexane. And then you have downstream.
Ethanol, right? Ethanol and heat.
Ethanol is another one. Pentane. Yeah. There's other methods of doing it. So these solvents, once you've attached it to the compounds and you moved it from the plant, well, now I got to get the hexane off so we can consume it. And so there's a lot of downstream refining that has to happen to make sure that now in the US, we're really blessed because we have like the FDA who can govern that. Globally, there's some momentum, I would call it, or some conversations around, one day maybe eliminating or banning hexane as a stripping agent. It's a very nasty chemical. It requires really aggressive kind of mitigation techniques in building a facility to deal with it. It can be hazardous to people, not just from if you can't get it all off, but like operators that have to work in there. A lot of it's highly regulated, and most companies, do the right practices. So another solvent is supercritical CO2. So we didn't invent this method; it's been around for decades. And what's great about supercritical CO2 as a solvent is once it's done its job, it dissipates, right? So it's gone. It's a little magical that way, but it can be very effective at attaching to these compounds and pulling that away. There are some challenges with that technology as well, but you think about most of your cannabinoids or cannabis extraction uses supercritical CO2. It's also used to decaffeinate coffee because it can be very effective at it. It's not very efficient at it, and it can be expensive. And I sort of liken traditional supercritical CO2 process to, I was trying to I keep thinking of analogies that might explain where we are now versus what the traditional method is.
Well,
And
could the traditional method be more kind of like steam distillation?
that's another way of separating
Yeah,
things for sure.
but then that takes forever. And
Exactly.
it's drip by drip versus where you guys are now. Like, what is the thermodynamic, I guess, process when it comes, in terms of what you guys are doing compared to like very age-old type distillery?
Well, here's the way I would think about it: is if you think about how communication was handled a few hundred years ago, right?
Mm-hmm. Yeah.
And you wanted to communicate with somebody on the other side of the country. This is the days of like Pony Express, right? So you had to get your parchment out, your quill, your ink. You had to, think about and write out your message. Then you might use like a candle or wax to seal it. Then you had to get it to the first rider in the chain, and then it would, the communication would work. It would get all the way to the other party, and then but it would take maybe weeks, certainly maybe months before you even got a reply. It worked. That's how we get it. So that's how I sort of liken traditional supercritical CO2. And let's compare that to email. Email is I send it, it gets received instantly. I get a reply back in minutes, and it's far more efficient and ubiquitous, right? We don't use the Pony Express anymore for a reason. That's kind of the step change that we're talking about in what we've developed and have patented. And the reason is it can still leverage the same principles, right? The communication's getting there, right? But now it can do it at a scale that just really hasn't been contemplated. And that's really exciting to me. And part of that year spent talking with customers, we talked to a lot of our clients are literally experts in supercritical CO2 extraction. And when they see what we're doing to allow it to scale, they're like, oh my God, you guys have solved a lot of the challenges. And some of the things that have held it back from scaling, mostly the math didn't work, right? It didn't make sense. It doesn't make sense. The math doesn't work on the cost of this long involved process versus what we're doing now.
Right.
And so where in some cases using supercritical CO2 for industrial scale has been ruled out because of that, we're now rolling it back in as a consideration. And so the biggest changes that we've done is thinking about it in an industrial setting versus a lab setting, and so that's really the transformation, which is eliminating some of the material handling. So in a traditional system, there's going to be a certain amount of manual, there's grinding and bagging the material before it goes into your process chamber. There has been a belief that you basically need to pump liquid CO2 into this chamber that's now got your biomass, whatever you're going to strip out. You need to allow the CO, you need to bring it up to supercritical pressure, which is very high pressure. And then you need it to saturate that material. And sometimes that can take anywhere from 40 minutes to 24 hours before you can run the extraction. Some of the really large plants to extract for decaffeination, they might have like a resident time of 16 hours to run, to wait for that CO2 to do it.
To absorb.
So what we've done, and it was sort of interesting when our founder went out to talk to some of the experts, we use a little bit different approach for how we bring the CO2 in and get it to supercritical. Most systems would use a high-end electric pump which is high energy consumption in order to whir it up, right? And that's going to take at least 20 minutes. Then you've got your soaking time, and then you've got your extraction cycle in order to extract out these compounds. So we use hydraulics to do that much faster.
Okay.
So we're able to do some things there, but we also eliminated the pre-step of the grinding and bagging up front. So we can use the hydraulics as what is known as a cold press. So if it was like a stone fruit, you want to get access to the things inside. That's why you would grind it before. Instead, we use hydraulics you can crush it, and then you can flood it with CO2, and then you can compress the volume in the chamber. I'm trying to do this in my camera to bring it supercritical in about a half a second. And
in half a second?
Yeah.
Okay, so
well, and let me just finish one thing. What we're able to do then is we can run a cycle on that biomass in 5 to 15 minutes and get similar yield out of that biomass as the industry standard.
So you're taking something that will typically run anywhere right now from 24 to, let's say, 48 hours, and you're able to use your technology, which is more sustainable because it's not using as much energy, electrical energy, to work. Instead of it's using the hydraulic effects to quickly saturate and fully saturate the solid biomass. And then you're still able, even though in a short period of time, a few minutes really, to get the same amount of yield that what was done before would take much longer. So I think it would be interesting to know from start to finish, which I know you've sort of explained now, but I think if we can maybe compact that into an example for, like, who are your customers right now? And maybe we can use like something like, whether it's pomegranate skins or grape skins, and kind of walk us through that process. So you get a customer. And then what?
Yeah, so maybe it'd be a good idea we have a customer that's in the hops business that is a hops farmer.
Okay.
For them, they actually saw an opportunity to be more sustainable, but not using their waste, but using their hops that they grow to extract some of the specific oils that produce the flavor and the bitterness for a craft brewer.
Okay.
So the challenge, though, is that they were looking for very specific characteristics in this. It's like a hop terpene, and the challenge is how to extract that cost effectively without going through all of these steps. So they were our very first customer, and it was a little bit of a challenge at the time for, hey, we see what you guys are doing. Can you produce this particular product? And the benefit is essentially the brewer will put in bushels of hops into their vessel, right, to boil out the oils, to give their beer flavor and bitterness, right? And so the idea here is the challenge with that method. And as the farmer kind of said, the only way for us to really grow revenue is to add acreage. And with climate and pests and all kinds of other things, there's no guarantee that that's going to actually yield a better result.
Right.
So instead, they said, if we can, help a brewer improve their yield, because after they've boiled these hops, now they got sop and wet hops to get rid of.
Right.
And so that's about 12% of their yield. The other thing is they've got the transportation and storage costs and storage under refrigeration of those hops all the way through and the disposal costs. So we have a chance to be more sustainable, because when you extract out these high value, kind of terpenes are really, really concentrated.
Yeah.
And so you don't need the same quantity of whole hops to put in. You can actually extract this very particular molecule. It's a compound that delivers a certain amount of flavoring that this particular customer is looking for. And it gives the brewer even more control over, a little more precision in the process. And so the good thing for them is those hop oils have the opportunity to save the brewer money, but they may cost somewhere in the neighborhood of $6 or $7 a gram. And so because you don't need to use very much of it, it still makes sense for the brewer. Right. And you also have the sustainability story. So when we look at that, that's a great example of, can you make being sustainable also profitable?
Right. But then you're also adding in ancillary revenue streams that are high value. So I would assume, right? Because if in this situation, it sounds as though the farmer not only can sell the hops to the brewer, but they can also sell this additional high value product.
Yeah.
So because when I think about plants, the phytochemical structure of plants, the chemical constituents can be very varied, right? From phenols to terpenes to all kinds of different sort of molecules. Is it the customer that determines what molecules that SCO2 should strive for? Or is this something that, in addition to that you guys sort of explore and see what other phytochemical constituents are within that biomass, for example?
Very good. You're exactly, yes. The answer is yes. Step one is, our customers really know what they're trying to do.
Yeah.
They don't have the process tech to get it done, right? So that's really step one. We do have a number of inquiries from people that said, Michael, what can we do with this waste, right? And they want to send it to us. I'm like, don't want it yet, right? And so we believe that we're going to be able to help map out the value chain in a lot of these different feedstocks, but we think that's step two. Step one is, we are helping our customers who know exactly what they're trying to do achieve that goal. And then when we do, it's going to open up new doors. And what's exciting is that there are right now in some cases, those customers want to just use it internally for their own new product development, existing product development, making things better, making the yield better, things like that. There are some that will say, we are creating a new product now that we can sell to the outside world. We're taking our waste, turning it into a revenue stream, and we'll go sell it into an existing market. So in some cases, it's a polyphenol, it's a flavor, it's an essence or something that exists today.
Right.
Some of the supply chains of those compounds may not be very sustainable.
Yeah.
They may come from harvesting that compound from an animal and not from a plant. And so there's usually an existing market that the customer could then enter, and we kind of look at it and say, why would they be able to show up and be a new customer or a new supplier of this particular compound? And if there isn't a reason there, then maybe they shouldn't, right? But what we keep finding are some common themes around traceability, around being more sustainable, around natural, sometimes organic, and in certain things that the discerning buyers of these compounds, whether that's in food products, in nutraceutical products, certainly in pharma, are going to be very discerning in terms
Right.
of where it came from, right? I mean, that's going to be vital.
Yeah.
And then I think there's a whole nother realm of kind of new and novel ingredients that
Mm-hmm.
can be developed with a
Right.
technology like SCO2.
Right.
And maybe in some cases it's been identified, but there's no way to commercialize it. And so maybe, I mean, there's a lot of, um, ancient Chinese medicine, right? But there's a lot of evidence in the world of people using plants for medicinal health.
Mm-hmm.
And in some cases, one of those bioactive compounds might be petrified tree bark. And the challenge is, how do you get it out without damaging it? And then how do you get
Right.
enough of it out to help the most people?
Yeah. I think that's so important because, I think you and I, we spoke about this. I owned a skincare company, which was natural organic, and we would, utilize indigenous plant materials that were organic. And so it was very important that everything had to be cold processed. Even our essential oils, we had to use supercritical essential oils because then
Mhm.
those fluids, again, that traceability, that, it can be important to some customers and they're willing to take on the cost because of the high value content. Whereas there are some companies that might not really be interested as much, but it's more about minimizing costs, and so they're willing to not make the investment in those sort of high value products. But
I mean, I think that's really interesting. As a food manufacturer, it's really mandated. The transparency and the traceability is mandated by the FDA,
right,
not necessarily around the world, but it's critical that we know where our things come from, our food comes from, and yeah, it's pretty clear. And in Europe, they're just passing or enacting a new law around deforestation, and
hmm
so I may have a little wrong, but I believe that if you have a product that's going to pass through Europe, you need to have signed on to this and be able to prove
right,
that you are not knowingly or maybe even otherwise contributing to any deforestation that's going on in countries of origin where some of these crops are grown. And there's some challenge with that for sure, and how we can, how do you regulate that? And there's a lot of smallholder farms where these things come from, and
hmm
there isn't a lot of systems that can get to that level of specificity on which smallholder farm, this particular product, whether it's coffee or cocoa or other commodity type, but high value, at least, we use them regularly.
right,
How do we then regulate that? So there's some pushback from large manufacturers about there's got to be a little give and take here. We can't do it all at once, but there's also a big movement to do more so that we
right.
can have that transparency.
Yeah, I feel like countries, or like institutions such as the EU and even Japan, they seem to be definitely ahead of the pack when it comes to regulations and commissions, and what traceability, sustainability. So it'll be interesting to monitor that and see how that can impact
Yeah,
multiple industries.
for sure. I think some of it's just land. We have
Correct.
land here; they don't have that, right? And so our ability to landfill doesn't make it right. Has been
Right.
a little out of sight, out of mind
Right.
for us now, because of regulators, because of outside pressures from both consumers, and then a lot of major food companies sell into all the major retailers, and they're starting to mandate more. So there's a little bit of a squeeze play, and by that I mean that um, food companies are typically facing price increases, So they're getting it from all sides. It's not just disruptions in supply chain, but there's inflation, there's higher cost of labor, there's a whole bunch of reasons for higher prices, but they're also being asked to be more sustainable.
Right.
Not only asked, but they're kind of being told, like, hey, we need you to do more. We need you to do it faster. We need you to prove to us that you're doing it as well. And they're a little stuck in the middle, saying, we're trying, right? It's not that we don't want to, but we're doing things. And so there's a lot of really good initiatives by a lot of really good companies. We're going to try to be an answer to help solve some of that for these companies, because, and that's why we're raising capital. That's why we need to accelerate our growth, so that, the timing is right now.
Right. And the timing. Yeah. Absolutely.
And the better timing was yesterday. Right. So,
exactly.
And there's a lot, what's good is there's a lot of, there's starting to become a lot more alignment in terms of finding something. I think there are certainly food processors that are looking for answers and are willing to take on a little bit of risk to explore and try to help themselves at the same time.
Right. That's really interesting. Can you give us some examples of the customers you're currently working with?
Yeah, I work with Ferrero Chocolate Company, global chocolate company. They're probably the single largest grower and processor of hazelnuts in the world. Palm Wonderful is a client of ours, with a lot of pomegranate waste that does have some high value compounds in that. We work with a greenhouse grower here in Minnesota called Bushel Boy Farms. And they're growing, it's called Bushel Boy Farms. And they grow tomatoes, cucumbers, strawberries, peppers, all under greenhouse. I think they have 48 acres of greenhouse. And in there, what's really interesting is, they lose some of the fruit, but but the vines and the trimmings and the leaves all have valuable compounds in them. There's no good way to get them out.
No, there isn't.
Right? And so that's really, this will be a first of its kind. And this is a company that's already incredibly sustainable. They, because of the way that they grow, and I've been to their facilities, and they're just remarkable on how they're able to, do this all indoors in the middle of a Minnesota winter, by the way. So it's really staggering. But the project that we have with them is, can we valorize these leaves and vines and some of the lost fruit, and keep it from going to compost or to landfill? And for them, it's a challenge that's sort of in this worth trying, category.
Yeah. And it sounds as though due to the so using this particular client, due to the complexities of the various feedstocks, so the inputs, the agricultural inputs, whether those are roots, the stems, the leaves, how is SCO2's technology, how is it designed to ensure high performance across all of these different inputs?
Yeah, usually where the hiccup comes is in the materials handling of all of this, right? So in any industrial application, right, I think there's a couple of principles that we've really held to. Is it's got to be pretty easy to run. It's got to flat out work. Has to have that reliability and dependability, and it has to be able to be consistent in what it's doing. So that, most industrial processes may need to run 24/7 for weeks on end. And so we've really designed, in some cases, overbuilt or over-engineered for those scenarios. And we put the extraction recipe in the machine so the operator doesn't have to spin dials and throw switches to do it. So the materials handling is important, because if we're automating this, you can't be bogged down by having a 5 steps to grind it, manually bag it. It has to be truly automated. And so,
Right.
and that could look like, you know, you dump it in one place and it augers up and goes into the process chamber where it can just load and unload on its own. The extracted materials can be captured downstream, and those can be automatically, you know, unloaded as well, so
Right.
that you don't have to be constantly. Now, yeah, you need a skilled operator, right? So there should be a good operator in a typical, you know, cannabis operation. You've probably got 12 steps. The supercritical CO2 is one.
Right.
You need highly skilled operators. You're taking the extracted compounds, and then you're usually using a co-solvent like ethanol
Right.
to be able to remove the waxes and fats. And each step along the way, in order to get to like a pure isolate to go into your gummy or something like that, you've used a number of highly specialized pieces of equipment that all have their own maintenance challenges as well, and care and feeding. And then you have highly skilled operators, scientists that are running that. So we've really tried to collapse all that into one end-to-end process.
Right.
And so what we're doing is, yes, with the hydraulics and all of that, that's helpful. We're also separating or fractionating these compounds straight out of extraction, which is really unique. And so the way that, and again, I'm not a scientist, but, you know, if we think about the supercritical CO2, will take the bulk of what's there, and then we're basically using that hydraulic ram to press it through into the collection chamber. But what we do is we go into the first collection chamber, and right now we have 6, we could have 12. But basically, as you bring the pressure down from supercritical back down to subcritical and back down to atmospheric, what you're doing is different compounds with different density will fall out of suspension in different locations. So it's kind of like a molecular sieve.
Okay.
Your bigger, heavier compounds will drop out first. That's usually like your alpha beta acids. Then you'll get your waxes and fats. Then you'll start to get your flavonoids, and then you'll get your aromatics at the end because they're lighter weight. So when we think about these bioactive ingredients, many of our clients will say, oh, we may be able to actually produce at scale multiple products in one step. And
exactly.
Yes. And that's why, and a lot of times it's what you get the least amount of that may have the highest value.
Of course.
And
yes.
Then,
especially in the plant kingdom.
Yeah. Well, and you know it from the skincare world. And, you know, one of our clients called it like a value stack. Right. And so a lot of times, and then our cost of operation and cost of maintenance is low. So that, you know, you don't need you know, the only way this works is if it returns a clear ROI, right? We're, you know, if we can make being sustainable profitable, now we've got CFO and the chief sustainability officer walking in the same step. And that's usually how we get support for our projects. So you need the business people and the science people together in the same room and say, this is why this could make sense. And so that's really where we are now, is in helping demonstrate that with our clients, because they want to see it work on their stuff.
Right.
You know, we have lots of data that supports, like, we didn't invent supercritical CO2. So that part absolutely works.
Right.
We've got third-party analysis on it and everything that says, yep, it does what it's supposed to do. The biggest thing is they got to see it work on their stuff.
Exactly. And I think the fact that you guys are able to, I'm assuming that your technology is portable, right? Like, can you talk about the CapEx requirement around this? Because so then that way people understand how it fits into most agri manufacturers and processors facilities.
Yeah, I mean, any CapEx project, capital expenditure, right, is going to have a business case built around why are we going to spend this money.
Right.
and what is the return. And so we can do things on a mobile platform. I would say that's probably to prove it out for a customer prior to a fully scaled implementation. But this would be equipment that would be placed on site at the customer, where the CapEx is really clear, right? The ROI is there. As you know, I was responsible for the CapEx in our juicing operation,
Right.
and so based on the CapEx cost that we're talking about is very much in line with what they're used to. And whenever they look at a project like this, they're going to ask for what's the internal rate of return? How do we make sure that this makes money? The access to the capital to support it is usually not the biggest hurdle. It's being able to really make sure that you've proven, and there's always the how do I fit it in here? But we're talking about a system that could maybe process 5 to 50 tons an hour, where the largest supercritical system, some of the largest ones, can do a couple tons a day.
And this is that it can actually scale up to 100,000 tons a day of processing.
50 tons an hour, right? Of processing, right? That can handle, and that matches the size of food waste, right? So we can tackle now. It's going to require a lot bigger pieces of equipment that we have now. But our model is we're going to license the technology to our customers, and then they'll choose who to build it with. Some of our clients say, well, we build all our own equipment. Literally, they build their own equipment. They don't use outside manufacturers, or they have preferred manufacturers that they work with. They'll license it from us, and then we'll help them build it and make sure that it gets done to the standards that we're giving them the designs for. But we'll do that for their specific application. So we'll give them an exclusive, maybe in Ferrero's case, we'll offer them an opportunity to own what they're doing with hazelnut. But that doesn't mean I can't do something similar with peanuts or pistachios or almonds. I mean, we're in the U.S. we're the largest almond growing.
Almonds. Yep, right here in California.
Yep. And if I was the almond board, I'd be trying to figure out how do we work with SCO2 to figure out everything that's possible to get out of almond waste.
Yes.
Because all of the shells, the skins, the trimmings, all of that has high value compounds on it. And what is known is that using supercritical CO2 to get those out, it's likely been studied in a lab, but that doesn't scale. And the application where even if it's proven, it doesn't scale.
Right.
So we're the connective tissue between kind of the proof and the commercialization that may be there, which is, again, we need a little bit bigger team to be able to go and do that. So when you talked about, are you going to sort of help identify some of these high value compounds that can be extracted? I think the answer is yes. I mean, ultimately, I think we'll be able to do that very, very effectively, and then help industry, tap into those markets for it. It's just going to be probably step 2.
Yes. Okay. So obviously you're targeting a $300 billion market, and you briefly mentioned that you guys are starting to generate revenues, and maybe that revenue model, part of it is licensing the technology out to those who maybe want to have to build out their own manufacturing, their CapEx, but then you can also work with those who don't really have the capability to actually build out the actual manufacturing equipment. So what is the revenue model only just licensing? Like, what does that?
Right now we do paid pilots. right?
Okay.
So our clients pay us and they send us their feedstock from wherever they are in the world. For now, we have our own R&D center in Minneapolis where we can run the test, and then we typically send it back to them for analysis or to a third-party lab for them to. What we're doing with them is basically iteratively
Right.
building that extraction recipe for
Got it.
what they're targeting, and so they pay us to do that. The idea and why I think we're working with some very large corporates is we're trying to make that process pretty easy, right? And so there's a lot of belief that we can solve a lot of problems, but we don't know until we've done it, right? Because it's a little bit of a new process that they want to see work. We want to keep this as quick and cost effective for them to prove it out so they can benefit from it. And so they may spend between, I don't know, $50,000, $100,000, $150,000 to help, as they, we kind of stage gate it, right? And say, look, let's just kind of help you validate your assumptions about this. And then let's map it out. Like with Ferrero, we have about 6 steps. And if we keep getting green lights, let's keep going. If we get a bunch of red lights and we can't put our heads together and figure out how to solve it, then maybe that's the red light. Maybe we're done there. That's okay with us, right? Because it helps. How do we prove or disprove it as fast and economically as possible? With our clients, I think the reason that we're able to work well with a big corporate, of course, there's always the, we're a startup, right? We're early stage. We move fast. They move slow. Right? But if they move slow, but they're still intentional about it, that's fine. They're big organizations. They don't turn on a dime. They have their, it's not just me and one other person, right? They have a whole team. They have a team that's in different time zones. They have a methodology that they want to follow. We accept that.
Yeah.
And we just have to try to, make sure we know if the motivation is there, then we'll get the alignment through the organization. And so most cases, the CEO of the company or the president of the company knows about our project because of the potential. And then it's up to kind of the science team or the open innovation team to then do the work where they've already got the budget mapped out. Now let's do the work to prove the case.
Yeah, to prove the case. And then once the case is proven, and it's really cool that it's actually a paid pilot, so you're not losing much money.
No.
And that way, once there are all these green lights, then you can now actually go ahead and do the full scale implementation,
right,
based on what they need.
Yeah, and we've already scaled up the tech several times, so we understand, how
that it is possible.
Oh, absolutely. Yeah. And there's some massive scaled CO2 plants out there for like decaffeinating coffee, and there's some really huge hop extract companies that do it a little differently than what we're doing. But it doesn't mean that the science absolutely works. But we're going to make it available to a lot more applications in a very cost-effective way, and help these companies not only create new revenue streams, but be able to measure their environmental impact. I mean, down to, for every pound of material processed through our machine, we can calculate that impact directly. From, because when it goes to landfill, that's going to be emitting methane. And we have partners that we work with on this side who can do the full life cycle analysis to really understand you're limiting the transportation costs, the handling costs, right? The landfill avoidance is huge, because then we're not emitting methane, which is, I think it's 20 times worse than carbon dioxide emissions. And so, there's the whole notion of upcycling is actually here to stay. it's like greenwashing is out and upcycling is in.
So it's the circular economy, but
exactly. All these buzzwords, right?
exactly. But I think another benefit, because especially in manufacturing, it's very hard because of this supply chain that can be so wasteful.
Mm-hmm.
It makes it improbable for a lot of manufacturing processing type companies to actually even qualify to be a B Corp, for example, right? Just because of the whole supply chain aspect. So if you, with SCO2 coming in, not only just, is it possible? Yes, it's possible. Can we extract new revenue streams? Yes, we can. Can we actually help you figure out your whole circular economy?
Mm-hmm.
Yes, we can. And can that even approve maybe or increase the potentiality of becoming a B Corp? And that could even be like an added, benefit to actually working with you guys.
Yeah, absolutely.
I know you mentioned, because when you start up working with large corporates, right, you did highlight that fact that cultural alignment, right?
Mm-hmm.
Startups are sprinters, and large corporates are, I don't know, what's
The
the
turtle
silver
in the hair, right? Yeah.
the turtles. And so how does a sprinter, like, can you give us specific examples, just maybe from a communication standpoint, just that misalignment and how you are able to actually overcome those?
Yeah, I think it really comes down to how you set up the relationship at the beginning.
Mm.
I mean, Ferrero was very honest. We do not move fast. And we said, okay, good to know, right? Like, so just some of that transparency is really important to understand. And then I think there's, authenticity of intention. And so when we sat down with them, they came to visit us. We asked a very simple question: is what's strategic for you? What are it's the rock in the shoe. What rocks are in your shoe that we can help you take out? And by being aligned at, kind of what's worth it, right? And let's not just extract stuff for extract stuff's sake. Let's go after something that is meaningful for your organization, to where we can get to a place where together we believe that this technology could, there's a there, right? And that's really, then we could be patient, right? And then it comes down to, are both parties doing what they say they're going to do? Right? And so we're not trying to convince anybody of anything, right? We're really coming to them and saying, hey, we think that there's real potential in this new technology or this innovation or breakthrough in a traditional method that may have a positive impact on your business. Here's why we believe that, but we don't know your world, right? You help us understand if you think there's an application, and then we can work together on it. And I think and we go into it with our eyes wide open. We say, we don't know for sure, but we believe that it's possible. It's going to take some iteration. But if we try something and it doesn't work, that's awesome, because we now know not to do that again, right? So if it's an iterative process and there's risk in it, but if they're sharing in that, like, R&D is messy. You might try a whole bunch of things. We did it in formulating products, right? We did it in launching products. We knew 70% might not ever make it, but the 30% that do carried all the cost of making it worthwhile.
Yeah.
And so, we look at it as almost any consumer product adoption curve, right? We're the new technology and we're looking for early adopters, right? And those early adopters will come to the fold because they want something that's new and different, and they see the potential in it for them. And then from there, once they're in, then we'll get the early majority, the majority, the late majority, and then the laggards, right? And so it's going to follow a very similar curve with what we're doing. And so our goal in the next 2 to 3 years is to have 2 to 3 of these industrial installations around the world that are demonstrating what the tech is possible before we pour more gas on the fire, right? And then say, okay, now we can go. So it's almost like we got to go slow to go fast.
Exactly.
It's a weird concept, right? But it's like, we have, I don't know, probably 15 NDAs from global companies right now that we've been talking to over that year I was talking about.
Mm-hmm.
And what was interesting to me is after a kind of high level conversation, they asked us if we would sign NDAs. And I said, oh, that's really interesting. I'm like, why are you asking us? These are huge companies. Well, they've got projects that they want to disclose to us to get our perspective to see if that might be an application.
Right.
And so, of course we said, yeah, we want to engage in those kinds of dialogues. If there's 15, there's 150, right? There's more out there. We've been asked in early conversations by 2 different companies that we should consider doing joint ventures. I'm like, wait a minute, this is way too early for a joint venture. But what's exciting is they see the potential of where this can go. Right. And so we're going to get there. And we're going to get there by being really intentional, probably a little selective in who we want to work with. And some of that's not the feedstock or the opportunity, it's the team that we're working with. Right. Because they're truly the collaborative partners that are going to help, where we can help one another get there. So that's exciting for us because we have a lot to do and improve, but we're already seeing the evidence of what this is going to look like at scale.
Yeah. I think it's pretty phenomenal that you've actually, when you talk about these large corporates, you have for sure, you have the wonderful company, you have a couple of other companies that are actually looking and partnering and working with you. So I think that's and these are companies that, even when you look at their branding and when you look at how they position themselves in the market, they've always been at the forefront of, sustainability and really thinking, being thoughtful and intentional when it comes to their brand positioning and how they work with their suppliers and their vendors across the value chain. So, like you said, it's that consumer adoption rate. You're going to have your first 100, and then it gets bigger and bigger, and then they're going to be followers and then laggards. I
mean, if you would have told me a year or 18 months ago that we would have the roster of connections around the world, around, the kinds of clients that we get the privilege to work with, I would have said I would have probably doubted you.
Yeah.
If you would have said this is where you're going to be in 18 months. So we're very blessed because we get to work on hard things, but things that we collectively think are going to be worthwhile and impactful. Right. And at scale, I mean, could we take 100 million pounds of food waste off the table? I think so.
Yeah. I think you guys are definitely on track to do that. Because right now the current solutions just really aren't there to do it in a sustainable way, in a profitable way. So you're not just saying we're just sustainable company, just, like greenwashing, but you are also generating revenues and you're close to tracking to some level of profitability. So you're able to prove that sustainability actually does work and it is profitable without the unnecessary incentives.
Yes. Yeah, absolutely. I mean, because that's when I think, boom goes the dynamite, right?
Exactly.
And I think that's been true for a long time. Like sustainability is often considered just a cost of doing business.
Mm-hmm.
And as soon as we can make that profitable, now you've got motivation to do more and do it faster and do it bigger, right? So that if we, and it may take a process technology or two or three to do that on, you know, for different reasons. And that's exciting because, you know, we kind of are in circles of other entrepreneurs who are doing really great things that are either in related spaces, but look, it's going to take a whole lot of us to break through. And I think, you know, there's challenges around, you know, I think about in a larger context is how can we support more companies like ours to prove or disprove them as fast as we can, you know? So like if the government is looking to give out grants, I would be looking at, I mean, you know, just this example that I just can't seem to shake is the USDA a couple of years ago, the apple farmers, mostly in Michigan, but in other parts of the country, there was a bumper crop, and it was the second year of a bumper crop of apples, but the trees still produce fruit. And when but they didn't have, there wasn't a home for it, right? The manufacturers were basically full. Their storage facilities were full. There was a backlog of apples and there really wasn't a great place for them. So the farmers are like, how do I pay my staff to go pick apples? Like there's nowhere to go with them.
Yes.
So the government said, oh, we'll help you. And look at it. Farming is incredibly difficult, right? And so this isn't a rub on the farmers, but it's the government said, we're going to buy up some of the excess apples and we're going to give them to homeless shelters and food shelves and things like that, which great idea. Look at it. It's a nutritious product that people need. And I love it. And then until I figured out how much they bought $200 million worth of apples in 1 year. That's one-time purchase, of which did pay farmers, pay laborers, right? It paid storage facilities or whatever else, transportation costs to move it around the country. But I was like, man, for $200 million, like we could have built, you know, selfishly, I'm like, oh, we could have built several upcycling facilities, bring in all of these things. And, you know, so I think there is a little bit of a access.
Maybe you don't need to sell the fruit. You could sell the juice.
Yeah, right. Exactly. But I do think that, you know, if we want to place a bet on, you know, entrepreneurs and being able to solve these problems, let's put our money where our mouth is.
Exactly.
You know, if, you know, a company like ours, and I think it should be gated where you're not just giving money away, but, you know, if we could have saved time of going out and talking with and fundraising and had been in a program that, you know, should have guardrails on it that could give us enough capital to prove or disprove SCO2 as fast as possible. If there's a there, I mean, it's patented for heaven's sakes, right? So now, and there's the promise of scale, you know, you know, how would I spend that $200 million? Well, I'd sprinkle it around to kind of the entrepreneurs who are beyond the napkin, before scale, and just try to accelerate whether they work or not, ourselves included. If you know, if ours doesn't work at the end of the day, it doesn't work at the end of the day. But it doesn't mean that, you know, the private markets are betting on us. We're betting on us. We think we're going to do it for sure. But I think from a systematic standpoint, and the role for the government would be, you know, a lot of the grants are we're not even eligible for, and they're trying to do waste reduction, food waste reduction grants. I can't get, and I'm scratching my head.
Why is that?
I don't live in the right county. I'm not the right ethnicity. I'm not a recycling center in my community. I mean, there's a whole bunch of rules. I don't have matching funds, right? So like, I actually posted something on LinkedIn about the Apple thing, and And I know one of the guys who works for the ag department here in Minnesota who said, well, hey, there are grants for things like that. And he sent me a link. It's like, great. Hey, awesome. Didn't know about it. I went to the link and it was expired and it required matching funds. I don't have matching funds. That's my problem.
Yeah.
Like I can't access it. So I think that plays out across a lot of my peer groups of how we're trying. I'm trying to, how do I accelerate that development timeline? How do I make sure that I can bring this to life? Sadly, a lot of good ideas and good products don't make it, not because of it wasn't a good idea. They just didn't have maybe the funding to get it done.
Right. Is it possible, given the challenges in when it comes to finding the right financial partners, that these customers that you currently have can actually be the ones to accelerate and scale the business?
Absolutely. Yes.
Yeah. Because it sounds as though, right now, obviously we have the CHIPS Act, so there's a lot of focus on, semiconductors and more of the industrial automation piece. So there's a lot of government funding toward that. And it sounds as though when it comes to the agricultural industry overall, that the funding is more about subsidies and not really enhancing as much the technologies that could actually enable farmers and processors and food manufacturers to not just rely on subsidies, but to actually tap into solutions such as what you guys are doing at SCO2.
Yeah, I mean, I don't know all of what's available, probably, right? But
yes.
It is kind of the way that it appears, right? And we can and we should reward farmers for best practices when it comes to taking care of the land and producing food. I mean, I live in kind of America's breadbasket, with in the Midwest, and California has every major agricultural product. It's just an unbelievable. I mean, you just drive north to south, and you'll see every crop that you can even imagine. And so we're doing the work, and we should continue to foster that. Whether we produce enough food to feed the world.
Mm-hmm.
Right? There are some logistical problems, and there are some broken parts of our system. But there's a whole lot of people that are, working on this, and it's really complicated. It's a lot connected, and it's not easy. I mean, you've got, consumers that, the nice thing is that consumers, particularly younger generation, they're starting to vote with their wallet based on how foods are being produced,
Right.
whether that's with upcycled ingredients, whether that's with regenerative agriculture, whether it's with just being a transparent, a brand or producer on what you're doing. And we are seeing that consumers will maybe pay more, maybe be more selective in what they're doing. I mean, the movement of food as medicine is very real. I was just at a conference this morning called Food Ag Ideas Week, and we were talking. One of the women speaking was, I think the average cost per person of healthcare is $13,000 a year, and the average amount we spend on food is $5,000. So it feels like it's a little out of balance.
We need to flip that equation.
That's right.
Yeah. Okay. So you've talked about the journey to get here with this emerging technology, and we talked about the industrial food processing landscape. Where do you see SCO2 in the next 5 years, and what other emerging trends or technologies do you see complementing the molecular precision of supercritical extraction?
I think in 5 years, I would like to see that we are setting a new standard in supercritical CO2 extraction globally, that we've got real world examples of how it's
Yes.
being done, and that we're walking the walk at that point.
Yeah.
There's a lot of really interesting technologies, I think, that we're going to be seeing. I mean, this conference was about regenerative agriculture and being good to the soil, and how we have the opportunity potentially to create more nutrient dense foods to consume and take care of the environment at the same time. They don't necessarily have to be mutually exclusive. There's a lot of energy around alternative proteins, and that's part of that feeding the world mentality. Is we need to find more scalable economic ways of getting protein into people's diet around the world. And so there are all kinds of alt protein companies, well beyond where Beyond Burger and Impossible Meats are, but doing something similar. Where can we really grow and produce proteins that are not animal based? So there's a lot going on there. I think it's going to be really interesting to watch. I went to a conference 2 years ago, and they only served alt protein food. And it was like, if you would have dropped in from outer space, you would have thought we were in an existential crisis on meat, because it was like, I was like, wow. I mean, and it was all around, kind of the future of food tech and things like that. But so that, I think we're going to see more of that. And I think we're definitely going to see a lot more in functional foods. Food is medicine. There's going to be even more. I mean, I was in the functional beverage space where we were, doing what we could deliver on that promise, but we're going to see it from a lot more foods that aren't mainstream in our diets. I mean, mushrooms and, all kinds of root vegetables and things that I think are coming down the pike. There's a lot of activity around that. And then we're definitely going to see more upcycling. Upcycling ingredients are going to become a lot more mainstream and sort of expected. Once we can scale these different methodologies, and ours is one. The other one is like drying and grinding it into powders and including it into different foods. So we're going to see a whole new landscape over the next 5 years.
Yeah, it's pretty exciting, actually, just a lot of the advancements around this and the exploration. And speaking of exploration, I have a moonshot question.
Okay.
So in conducting my research for this podcast episode, I stumbled upon a 2014 scientific manuscript written by German astrophysicists that suggested supercritical CO2 might support living processes in exotic planetary environments. Given that we are becoming a multiplanetary species, I would love to know what comes to mind when exploring this possibility.
God, way over my pay grade. It's a great question. I don't really know. I think if we can figure out how to grow things, in those environments, we can figure out how to get the most out of them, right? And have a zero waste kind of mentality where a process like ours could come to play, where we're microdosing bioactive compounds. I don't know, but the principles could certainly still work in that world. But it's a cool thought experiment, but I don't know.
Yeah, I'll have to send you a link to the article. I thought it was actually quite interesting, because I think what they were pretty much saying is that because of the supercritical CO2, the fluids that are generated from that have been found, and I think they were linking this to Venus, and how they found that the different components that come out of that, because of the I don't know if it's the velocity. I can't remember exactly what the scientific research was, what metric they were using, but they were saying that it is possible that this could actually be used when we decide to move into space.
This is a good question for my business partner, Olaf, who thinks in these terms. He'd be like, oh, I know the answer, but I don't know.
That's pretty cool. Yeah,
send it to me, please.
It's just a moonshot, and I think that's what makes future thinking exciting. It's like, oh, what is the possibility?
Well, I have a moonshot kind of concept that we've thought about is, what if we could use supercritical CO2 to cure cancer, right? Meaning, what are the next generation of pharmaceutical applications where we are? And what's really interesting, I guess, one of the other trends is using AI to help identify not just the bioactive compounds, but the combinations of them that can do the most good in human health. And so what excites us as a potential moonshot is what we understand from kind of the drug discovery challenges is not always that you can identify these bioactive compounds, but it's the harvesting of them without causing damage. And so what I don't know in the moonshot is that maybe we're not bound by the same rules of traditional extraction, that maybe we can apply this in a way that hasn't been factored before. One example of how we might do that is there's a physical limit on typical systems for how much pressure you could generate to drive supercritical CO2. Based on our methodology, we may be able to go up to much, much higher pressures to be able to draw out that extraction, but still keep it under 110 degrees Fahrenheit to not cause damage to that. And I look at it and I go, I don't know. I really don't. But if we can get some of these experts to say, is it possible? It might be in 5-10 years, maybe that's standard practice for how we do that. And that we could really, really move the needle on some of the world's nastiest diseases and by finding these things in nature.
Right. And that's why the concept food as medicine is so profound. It's simple yet profound.
Yeah.
And, it's also kind of juxtaposed or maybe diametrically opposite from the scientific path of, the classic scientific path of clinical testing, clinical trials. So it will be interesting to see how that can be bridged across.
I'm a big fan. Do you know Dan Buettner, Blue Zones?
Yeah.
So food is medicine.
Yeah, right? It is.
I mean, a lot of the blue zones, they eat what's available. They eat a diverse amount of foods, and their healthcare costs are very low.
It sort of attracts me to what you guys are doing at SCO2, because you're taking this complex piece of industrial processing and you're actually thinking it through. You're compressing 12 steps into one step. You're actually thinking about the upcycling, the circularity of where you guys fit into the supply chain piece. So that's really, for me, when I look at companies such as yourself, I'm like, wow, why didn't anyone ever think about that, right?
Yeah, I mean, I think it's just a different point of view of how we got here, because we really took a very different angle and thought about, could it be done? And then once we proved it on a small scale, we started growing it. And really, we kind of look at other industries where things are sort of proven and working, and kind of hybrid them to work in our environment, so that we address things like dependability, reliability, consistency, minimizing downtime and things like that. But putting the puzzle together a little differently.
Yeah. No, that's great. And I just recently reread Peter Thiel's Zero to One.
Mm-hmm.
It talks about this. Are you solving a large problem in a small market, or are you trying to um, go after the big market, which can be an impossibility,
Mm-hmm.
especially for a startup? And how are you actually um, making sure that you can have network, scale, network effects, and all of this? I feel like your approach, actually collaborating and working with the big guys and having them pay for that, so then that way at least you're generating revenue,
Mm-hmm.
you're able to prove that piece. I think it's pretty brilliant.
And when we reach kind of the next 2 to 4, 5 years,
Mm-hmm.
we're going to need to be in a bigger entity. We're going to need
Yes.
to have scale in
Mm-hmm.
order to get it out there further and faster. We've even had some discussions with a lot of leading universities about actually scaling our system down for more advanced R&D, and so that it can be done at a much, larger, there's maybe 1,000 applications. How do
Right.
we learn them fast enough? And so we've actually had some pretty interesting discussions already with universities who would love to, and some of them have supercritical systems. They just don't have one like ours that they could do things a lot more efficiently. And then knowing they would have a application that can scale
Mm-hmm.
is kind of it's a twist, because universities like to publish, right? They don't always think about commercial applications for it.
Yes.
So they want to prove something out. I'm like, this can help prove things out and commercialize that, which
Right.
will, which is a greater public benefit.
Yes, exactly. And yeah, so all awesome. I'm really loving this. So I have a closing round of questions
Okay.
that I like to ask. Um, the first one is, we are almost halfway through this decade. What excites you personally most about the future?
I see a lot of momentum. What excites me is about, how we're going to transform
Mm.
this food system is really exciting, and there's a lot of people working on it, which is great. And the solutions that are proven will be able to scale. And what excites me is that we still have the opportunity to um, produce maybe less food and still feed the world. We have a chance to reduce some of the climate challenges that we're seeing today, and I think that it excites me. We're in like another. I know this is going to be one of the questions. Is like we're in another industrial revolution, right? Of
We are.
just, I mean, it's incredible, and if you're not in it, maybe you don't see it. But there is so much going on, and I'm excited to see kind of the winners and the losers, and in the next 5 years, next decade, what really starts to get a foothold.
Mhm.
And it's up to us, collectively right now. And if we get the next 5 years right, we maybe get the next 50 right.
Yeah, I think especially with AI now, right?
Yeah.
Mhm. That's a very articulate assessment, that if we can get it in this next 5 years, as AI is ramping up and not, then I think we can definitely do more in the next 50 years. I really like that sentiment. Um, Second closing round question. I got this from one of my favorite podcasters and also Peter Thiel. So it's a compound question. It's a compound question, as all my questions are. Imagine it's your last day on Earth many years from now, and you've accomplished everything you've ever dreamed of. But for whatever reason, you can only take three things. You can't take anything else that you've created in this lifetime. No one will have access to any of that information anymore, but you get to leave behind three truths. What are the three lessons that you want to leave with the world? And what is one important truth that very few people agree with you on?
Okay.
You can see how my mind works.
Yes. Twist in there. Okay. I mean, I think about the three truths that are, be a good person, be kind. Uh, I think another one is sort of give it your all, right? Like a full effort. Like how do you, like, if you're going to do something, well, I don't like to do anything halfway. Let's do it all the way.
Right.
And then I think the last truth is having a positive attitude. I think I used to have this quote. I don't think I made it up, but I said, "Why not have a positive attitude? It doesn't cost you anything." And I think that's something that we could use more of. I think as we meet one another, it's like, why does your brain assume the worst? Maybe just assume the best. And maybe, yes. And what I like about those three things is those three things are things that are 100% in your control 100% of the time. You can be kind. You can choose to be kind. You can choose to give it your all, and you can choose to be positive. And yes. You can't, if somebody else can choose to be negative to you, you don't have to respond that way. Yes. You're in control.
Wow, I really love those three truths. So be kind, give it your all, and have a positive attitude, because at the end of the day, all three of those lessons, all three of those truths are 100% in each and every one of us, our control. And so those sound very fundamental to me, and I really like them. Yeah, so what is the one important truth that very few people agree with you on?
That's a good one. I need to give that more thought. I don't know. I mean, I just have a very determined belief that things are going to work out. And I think even though I think others would, think that I maybe stay with some things too long to be able to prove them out. But I'm like, I just feel like, maybe it's part of being a positive person, but, I want to, I sometimes can see things that, it's several links away, but, I don't know that people recognize that I'm trying to think several steps ahead.
Right.
But that the reason like this is hard right now is because we got to go over there, right? Like we're going somewhere. Don't you get that? But it's hard to communicate that when you haven't even gotten out of your own way yet. So exactly. I don't know.
No, that's an interesting sort of, I wouldn't say contrarian, but I would say, the ability, I believe, to see around corners, and as especially in your leadership position, to get people to go along with you, right. Because they don't see it, but you see it. And so, I think what's interesting about your three truths is that in that process, you could be the kind of leader who could be very toxic and say it has to be this way or my way. But it sounds your very principles of being kind and giving it your all and being patient actually probably allow you to be able to bring people along to that vision, even though they don't see it yet.
That's true. And that's, I think, style, right? As a leader, like a lot of times you see something in somebody that you work with that they don't see in themselves. And so how how do you foster that so that they get that aha moment and can take on that additional responsibility and then grow into that. And I've seen that happen with people around me, and it's really exciting, I think, when that stage of like human development, there is no embargo on ideas. Like ideas come from all over the place, and that is part of even as a small team, doesn't matter what hat you wear, we get together and my idea may be the least relevant, right? Because I'm not living in it every day. So the people who are living in it and who are, it doesn't matter where the ideas come from. And we love to foster this, let's prove it or disprove it. And when some of our younger team members, they all that didn't work, and they're get really frustrated. I'm like, oh, that's awesome. Now we know not to do that, right? And so there's if you can clear the kind of the opportunity for people to take risks in a safe manner, and you can encourage them to do that within reason, right? So you still need boundaries, but if they feel like there isn't going to be a judgment zone if something goes wrong, then you're going to foster a lot more creativity. Right. And you're going to solve problems faster.
Exactly. And also because they are on the ground, right? So let's say you install one of your machinery, hard tech, they're the ones who are operating the machines. They're the ones working with the client's team. And so if they don't feel safe enough in your leadership or within the culture of the company, then it makes it very hard for them to actually spot problems that they can now bring to the team to say, hey, maybe this is something we might want to consider. And that can be that 0 to 1 sort of, tipping point for you guys in terms of your technology. Yeah.
Definitely.
Okay. That's so cool. So what's your definition of a next-gen industrialist?
Okay. Well, knowing you were going to ask me this, I think the word that keeps coming to mind is bold. Right? And it's really people, and I think it's someone really willing to lean in to a belief that they can fundamentally change something for the better. And I think I hope I embody that. I mean, I hadn't really thought of the term next-gen industrialist, but like having talked to you before and now, it's like I get it. I mean, it's fostering these ideas, but I really think it's like being willing to be bold.
Yeah, especially nowadays, compared to the old guard, how things were done before, old type of manufacturing. And I think now that you have these next-gen industrialists who are coming up and saying, this could definitely be done better, and it can be done 10x better, not just incrementally. I think is pretty cool. And I'm definitely leaning into that because those are my clients. Those are my, I focus on the industrial sector. So it's really, really exciting and empowering just to see some of the things that are being built and going on. So Michael, I put your email scrolling across the TV, and anyone who wants to get in touch with you can do so right there. And I will also...
I'm findable on LinkedIn for sure.
Exactly. And on LinkedIn, as we all are. And then we'll actually also drop that in the show notes as well. So this was such an insightful conversation. Michael, I really appreciate your time. So I'm just going to go ahead and close out. It is clear that SCO2 is proof that the next industrial revolution is not just about creating something revolutionary. It's about reimagining what we already have. As we've heard today, the future of agricultural technology lies in seeing opportunity where others see waste, in being bold, in being daring to challenge the status quo, and in creating solutions that benefit the triple bottom line, and that's people, planets, and profits. If you enjoyed this episode, don't forget to subscribe, comment, rate, and share it with your network. This is Belinda Ephraim for NextGen Industrialists and Michael Sigel with SCO2 as we continue exploring the ideas and leaders revitalizing America's industrial base. Until then, be kind, be curious, keep innovating, keep disrupting, and keep pushing the boundaries of what's possible. Have a great day.
Thanks, Belinda.
You're welcome, Michael.